All right, we're going to talk about different muscle contractions and then a couple different concepts in this section that might have been confusing to you, just so you understand, like from an application standpoint, what this looks like. Because I think these are all really common concepts, but when you read them and you're reading them in the module as well, it can get a little confusing. So when we talk about contractions, you might have even heard the differences between concentric and eccentric and isometric. So when we talk about that, concentric is the shortening of a muscle, eccentric is the lengthening of the muscle, and then isometric is when you're contracting the muscle but not moving in a range of motion. It's just staying still. Now that's a really basic concept and something we use all the time. But when we are challenged to think a little bit more deeper into like the pathomechanics and biomechanics of, well, why are these contractions happening? It's important to understand that as we start diving deeper into injuries. And we want to use the term torque and understand how torque affects and creates those types of contractions. So torque is going to be the force when the joint itself is moving. So it's anytime there's a force around a rotational axis. So that means that there's an axis and there's lever arms that are moving. So we have in the human body, every injury that we talk about is pretty much going to be revolving around a joint. So that's why it's really important to understand this concept. So when we talk about these concentric versus eccentric and isometric, I think talking about the elbow is important and it matches up with the module page and the textbook as well. So when we talk about doing a concentric contraction, we're talking about shortening, and the bicep is the muscle that is creating that movement. So whenever you're thinking about what muscle we're talking about, what is the primary mover here? The agonist. So what muscle is moving and primarily causing that movement at the joint? So we are doing elbow flexion. We are bending the elbow, and the primary mover is going to be the biceps. So in this biceps, we have to contract the biceps and shorten it to bend the elbow. At the same time, our antagonist, our muscle in the back, which is our tricep, is lengthening, and it is having an eccentric contraction. But we are talking about the primary mover, the biceps, right now. So the biceps is concentrically contracting and shortening. In order for that to happen, the torque produced through the biceps has to overcome the weight and the mass of my forearm and my hand. Also, if I put in a cup of coffee, it now has to overcome all of that. So the amount of torque it takes to bend my elbow has to be more when I'm holding the coffee versus not, right? So whatever weight I have in my hand in this lever arm has to have more torque to overcome that. Also, remember, if I add weight to the length of the lever arm, I'm increasing the amount of torque here. Okay, so concentrically, I'm having torque build up in my biceps to concentrically contract and cause a shortening here. Then, in order to have an eccentric contraction of my biceps, I'm having to lengthen. So the torque of my forearm and my hand is overcoming the torque of my biceps. So for that, I would need something really heavy. Let's say I had a really heavy cup of coffee in my hand and I couldn't hold it and it took my arm down. That meant that the weight and the mass in this coffee cup created a torque that was greater than my biceps, so that I created an eccentric contraction. If I'm just lengthening the arm here and it's not because the mass overcame that torque, it's because now my triceps is now concentrically contracting to extend my arm. So it gets a little complicated. So just understand that when we're talking about concentric, we're talking about shortening. So whatever that primary mover that is shortening is doing the concentric contraction. Whatever that primary mover is lengthening, that is the eccentric contraction. Then if we're not moving at all and we're just creating a muscle and we're contracting maximally, that's our isometric contraction. As I also referenced, there's the agonist and the antagonist. The agonist is the primary mover and the antagonist is the opposer. So if a muscle is concentrically contracting, the opposite muscle on the other side of that body is eccentrically contracting. So when that biceps is concentrically contracting and shortening, my triceps is now eccentrically and lengthening, but it still has tension and it's still contracting, it's just lengthening. And then the last concept is passive versus active insufficiency. So we talked about that there are muscles that contract two joints, and these muscles undergo a lot of stress. So for example, we have our finger flexors that run all the way from the inside of our elbow all the way down to our PIP and our DIP joints to flex our fingers and our wrist. So it's doing a lot of function here. So when we talk about active insufficiency, we talk about if this muscle is actively contracting, but it's being stretched at the joint before that, it's not going to be able to produce as much force and contraction. So if I'm trying to make a fist, I'm making a full fist and I'm able to flex my fingers as maximally as I can. Now, if I open up and I bend my wrist, now those muscles are on a stretch, and I try to do it and I'm not able to make that fist. I'm not able to flex those fingers or produce that force anymore. Now, same thing with passive. It just means I'm stretching them. So instead of actively contracting them at the wrist, I'm going to just stretch them out. Same thing though, I'm not going to be able to completely flex them. I'm not going to be able to produce that same amount of force. So if you have any questions about these concepts, they can be confusing, please reach out.